lux, is Latin for light. This is a measure of the intensity of light, as perceived by the human eye. 1 lux is based on the amount of light a plumber's candle illuminates a 1 meter square surface, placed 1 meter away. We use a lux meter to measure the level of light. A lux meter mimics human vision in 2 key ways. Its sensor matches our eye's light sensitivity, peaking at green and yellow. Its lens captures a similar field of view to human peripheral vision. This dual approach lets it measure light in the same way we perceive it. At 1 meter, the reading is 1 lux. From this information, we can work out what the readings will be at any distance. Place your lux reading from 1 meter away at the top. Then the distance required. 2 meters. Square the distance. 2 squared is 2 times 2. 1 divided by 4 is 0.25. The lux reading at 2 meters will be 0.25 lux. What will the reading be at 10 meters? Square the distance. At 10 meters the reading will be 0.01 lux. All light travels in this mathematically predictable way. It's a law of physics. The inverse squared law for light. Let's let Professor Eric Rogers explain the inverse square law with his famous butter gun.
That with a fable. Suppose a restaurant has the problem of buttering toast and wants to be very modern and do it with a machine. So the proprietor invents a butter gun with melted butter in here, which can be squirted out in straight line spray of butter like that. Here's the piece of toast, and lines of butter go out and hit it there, and there, and there, and there, and butter it all over. Now instead of that, lines might go on, and you could put the toast further back at twice the distance, 2 pieces of toast wide, 2 toasts high, and altogether you would put 4 pieces of toast there to intercept the butter, and you'd be quarter a stick buttering. Inverse square law. At 3 times the distance, 3 pieces of toast, 3 pieces of toast, altogether 9 pieces of toast, and you would get 1/9 of the buttering economy treatment.
The first toast at 1 meter has 36 butters, or 36 lux of light. At 2 meters, the 36 lux or butter is spread over 4 square meters. The meter reads just 1 square meter of that area. This continues. At 6 meters your meter will read 1 lux. As the light at 1 meter is now spread over 36 meters squared. Light is extremely good at speed. But it's not that good at keeping bright over distance. From 1 to 2 meters the brightness falls to 1/4. At 10 meters 1/100th. On a moonless dark night, for a human to see a light source, at least 0.0001 lux of its light must reach the eyes. Below that, it will be invisible. Criquet Lighthouse in France is considered the most powerful lighthouse in the world. From 1 meter of the light, it would measure an incredible 500 million lux. It has a range on a clear day of 69.5 kilometers or 43.2 miles. As powerful as it is, at 10 kilometers, the lux reading from the light would only be 5 lux. At 69.5 kilometers, the reading will be 0.10351 lux. Allowing for a small loss due to the atmosphere, it will soon be below the visible limit. We have confirmed the lighthouse range, using the inverse square law, for light.